The lesson outcome for this video is graphing parabolas in Vertex Form using a blank table. So it all comes down to being able to graph an equation of a parabola from Vertex Form just without having any other information provided for you. Okay, and so what we're going to be able to do here is quickly find the vertex like we've been doing in the last couple of lessons, putting that into our table, okay, and then coming up with at least two more points that will help us draw our parabola. So the first thing we're going to do is use our shortcut for finding the vertex, and the shortcut, remember, is to use the value here and here for h and k. If it's x minus h, remember that x minus 5 will tell us our x-coordinate for the vertex is 5, not negative 5, but positive 5. And then our y value for our vertex is positive 3, as it is shown. Again, the positive 3 shows up as a positive 3 here, but the x minus 5 tells us we're going to have a positive 5 right here. So we know that is our vertex. And we can plot that point on our graph at 5, 3, which is right here. And now we know, because we've been talking about this a value here, we know that the parabola is going to open up. Okay, and it's important that after you do find two additional points to graph, that your ending result is a parabola that opens up. If it does not, you probably have done something wrong in your math. So what we want to do is we want to see how the parabola is going to open up from this point. We know it's going to open up in this kind of fashion here because of this 2 value. It's not going to be super narrow, but it's also not going to be very wide. It's going to be somewhere in between, like right in this region here. Notice also with this very first example that we did, because it's going to open up and the vertex is here, we aren't going to have any x-intercepts, which means that we wouldn't have been able to graph this in the way we did at the beginning of this unit, because we wouldn't have any x-intercepts. So how can we find a couple other points to plot so that we can graph our parabola? Well, what I would suggest is taking just one value greater than the x value of your vertex of 5 here, and take one value greater, which is 6, and find that y value, and then take one to the left, which is 4, and find that y value, and plot those points and draw your parabola. So I'm going to use 6 as one of my options, and I'm going to use 4. And again, when you put those values in for x, we can rely a little bit here on our calculator as long as you're using parentheses correctly in the calculator. Otherwise, we can do it just using our order of operations skills. So if I wanted to put a 6 in here for x, I would do then 6 minus 5 is 1, and 1 squared is still 1, because 1 times 1 is 1. And multiply that by 2, which is 2, and then 2 plus 3 is 5. So our y value when x is 6 is 5. So our point 6,5 is on the parabola. 6, 5 is this point right here. All right. And we can put another value in, let's say 4. Maybe I'll make that one purple here. So what if I put, instead of the 6 in, I put a 4? Well, 4 minus 5 is negative 1. And negative 1 squared is negative 1 times negative 1, which is positive 1. Times 2 is 2, and then 2 plus 3 is 5. So we got 5 again. So if I plot the point 4, 5, it's right here. Now, doesn't it make sense, because of what we've learned about parabolas, that those 2 points will have the same y value since they are both one point to the left and one point to the right of the vertex? Remember, we have a line of symmetry here through our vertex. It's always through our vertex, the line of symmetry. So if I were to fold the parabola on itself, this side here would be a mirror image of this side here, which then would make sense that these 2 points that we found have the same y value. So we're going to curve this up and to the right, and similarly up and to the left, and there's our parabola. Okay, let's just try one more example here of graphing a parabola from Vertex Form with a blank table. Again, sometimes you'll look at this and you'll be like, I don't even know where to start. Well, you have to think through what we've kind of learned about quadratics. First of all, don't don't mind me here, I'm going to change this problem just slightly to have a negative out in front. So if you had already written that down, let's change this right here to a negative 1/2. So what we know about vertex form is that it's called vertex form because you can easily find the vertex. So that's a great place to start if you feel stuck. To find our vertex, which is HK, remember that we're going to use the opposite of what you see in the parentheses. So instead of +2, you're going to use a -2. And then you're going to use this value here for K, or your Y value of your vertex. So -2, -6 is the value we're going to use, or the point we are going to have for our vertex. So -2, -6, you can plot that right here. And then once again, if you think about the front value, the A value, as being -1/2, first thing we know is, again, this example opens down. Okay, and if it opens down, in this example, since this is our vertex right here, if it opens down, it's not going to have any x-intercepts. So we couldn't put we could put a 0 in for y and solve, but we would get no real solutions. So we wouldn't be able to find our x-intercepts. So there has to be a different way to graph our parabola. And again, we have our vertex, and now we just know that it's going to be going down in some fashion down here. We also know that since this is a 1/2, it's between 0 and 1, that it's going to be a wider parabola instead of a narrower parabola, a little bit wider than the parent function. All right, so how do we find these other values? Well, we can choose whatever x values we want to find their corresponding y values, but let's use a good choice for those x values. If we simply choose an x value to the left and to the right of this point right here, we can graph our parabola. So how about -1 as one of our x values, -1, and then maybe we could use one to the left of that, which would be here, and that's at -3. So we'll use -1 and -3. We'll put those into our equation and find the corresponding y value. This time I'm just going to go ahead and show that work. So we have y equals -1/2. The x value we're going to put in first is -1, putting that in, plus 2 squared minus 6. Again, using your calculator is just fine here, but working on our order of operations is not a bad idea. So -1/2 times -1 plus 2 is 1. Just going through the order of operations. -1/2 times 1 squared is 1 times 1, which is 1. -1/2 times 1 is -1/2. And then we have -1/2 minus 6. What we get here is y equals -6.5, or 6.5. So -6.5, which means that point is actually very close to our vertex, but we can plot it, -1, -6.5. So that will be right here. Okay. And now if we did the same thing with -3, so instead of putting a 1 here, we can put a -3, and I'll walk through the work there, just fixing things here as we go. So -3 plus 2 is -1, and then, pardon me, -1 squared is -1 times -1, which is still 1. And now the rest of this work is exactly the same. -1 times 1, I'm sorry, -1/2 times 1 is -1/2 minus 6. So again, we get -6.5 again, or 6.5. And if we go to -3, -6.5, that is going to be right here. And then we can graph our parabola, which will open from the vertex down through that point and through that point there. And there's our parabola.